The fuselage is an aircraft's main body section that holds crew and passengers or cargo. In single-engine aircraft it will usually contain an engine, although in some amphibious aircraft the single engine is mounted on a pylon attached to the fuselage, which in turn is used as a floating hull. The fuselage also serves to position control and stabilization surfaces in specific relationships to lifting surfaces, required for aircraft stability and maneuverability. Types of structures. Truss structure. This type of structure is still in use in many lightweight aircraft using welded steel tube trusses. A box truss fuselage structure can also be built out of wood, often covered with plywood, as can be seen on this ibis canard fuselage. Simple box structures may be rounded by the addition of supported lightweight stringers, allowing the fabric covering to form a more aerodynamic shape, or one more pleasing to the eye. Geodesic construction. Geodesic structural elements were used by Barnes-Wallis for British Vickers between the wars and into World War II to form the whole of the fuselage, including its aerodynamic shape. In this type of construction, multiple flat strip stringers are wound about the formers in opposite spiral directions, forming a basket-like appearance. This proved to be light, strong, and rigid, and had the advantage of being made almost entirely of wood. A similar construction using aluminum alloy was used in the Vickers Warwick with less materials than would be required for other structural types. The geodesic structure is also redundant and so can survive localized damage without catastrophic failure. A fabric covering over the structure completed the aerodynamic shell. The logical evolution of this is the creation of fuselages using molded plywood, in which multiple sheets are laid with a grain in differing directions to give the monocoque type below. Monocoque shell. In this method, the exterior surface of the fuselage is also the primary structure. A typical early form of this was built using molded plywood, where the layers of plywood are formed over a plug, or within a mold. A later form of this structure uses fiberglass cloth impregnated with polyester or epoxy resin, instead of plywood, as the skin. A simple form of this used in some amateur-built aircraft uses rigid expanded foam plastic as the core, with a fiberglass covering, eliminating the necessity of fabricating molds, but requiring more effort in finishing. An example of a larger molded plywood aircraft is the de Havilland Mosquito fighter light bomber of World War II. No plywood skin fuselage is truly monocoque, since stiffening elements are incorporated into the structure to carry concentrated loads that would otherwise buckle the thin skin. The use of molded fiberglass using negative molds is prevalent in the series production of many modern sailplanes. The use of molded composites for fuselage structures is being extended to large passenger aircraft such as the Boeing 787 Dreamliner. Semi-monocoque. This is the preferred method of constructing an all-aluminum fuselage. First, a series of frames in the shape of the fuselage cross-sections are held in position on a rigid fixture. These frames are then joined with lightweight longitudinal elements called stringers. These are in turn covered with a skin of sheet aluminum, attached by riveting or by bonding with special adhesives. The fixture is then disassembled and removed from the completed fuselage shell, which is then fitted out with wiring, controls, and interior equipment such as seats and luggage bins. Most modern large aircraft are built using this technique, but use several large sections constructed in this fashion which are then joined with fasteners to form the complete fuselage. As the accuracy of the final product is determined largely by the costly fixture, this form is suitable for series production, where a large number of identical aircraft are to be produced. Early examples of this type include the Douglas aircraft DC-2 and DC-3 civil aircraft and the Boeing B-17 Flying Fortress. Most metal light aircraft are constructed using this process. Both monocoque and semi-monocoque are referred to as dressed skin structures, as all or a portion of the external load is taken by the surface covering. In addition, all the load from internal pressurization is carried by the external skin. The proportioning of loads between the components is a design choice dictated largely by the dimensions, strength, and elasticity of the components available for construction and whether or not a design is intended to be self-jigging, not requiring a complete fixture for alignment. Materials. Early aircraft were constructed of wood frames covered in fabric. As monoplanes became popular, metal frames improved the strength, which eventually led to all-metal aircraft with metal covering all surfaces. Some modern aircraft are constructed with composite materials for major control surfaces, wings, or the entire fuselage, such as the Boeing 787. On the 787, it makes possible higher pressurization levels and larger windows for passenger comfort as well as lower weight to reduce operating costs. The Boeing 787 weighs 1,500 pounds less than if it were an all-aluminum assembly. Wing integration. Flying wing aircraft, such as the Northrop YB-49 Flying Wing and the Northrop B-2 Spirit bomber, have no separate fuselage. Instead, what would be the fuselage is a thickened portion of the wing structure. Conversely, there have been a small number of aircraft designs which have no separate wing, but use the fuselage to generate lift. Examples include National Aeronautics and Space Administration's experimental lifting body designs and the Vought XF-5U-1 Flying Flapjack. A blended wing body can be considered a mixture of the above. It carries the useful load in a fuselage producing lift. A modern example is Boeing X-48. One of the earliest aircraft using this design approach is Bernoulli CBY-3, which fuselage was airfoil-shaped to produce lift. Gallery. See also, airframe, empennage, nose art, aviation accidents and incidents, external links, NASA page on fuselage, Institute of Aircraft Design in Lightweight Structures.